Welcome to Distributed Replay, testing with your data your way. My name is Melody Zacharias. I'm a business intelligence architect. I'm a chapter leader for PASS and one of the regional mentors for Canada. My contact information is here on the slide if you want to reach me after this session, if you have any questions or would like a copy of the slide deck. That would be the best way to reach me, probably at email, and you can always follow me on Twitter. So why distributed replay? During our session today, we'll discuss the why, what, and how of distributed replay, as well as touch on a few tips at the end just before we get to some questions. So we'll leave our questions today until the end. Why distributed replay? Distributed replay allows you to simulate your chosen workload on a test system. This allows you to run a production-like workload against a test system to monitor and evaluate potential performance, upgrade, or functional issues, as well as capacity planning. It's truly only limited by your imagination. But why not use a third-party tool? Typically, third-party tools don't use your data. Sometimes getting the approval to run a Microsoft tool in an environment that is already using SQL Server is a much easier sell to management. As a consultant, I recently went to a client to ask to run this in their production environment. All approvals of this type had to go directly to the CEO, as it is a bank. This was not a typical request. Once I explained it was a tool that came with SQL Server and was a Microsoft product, and all I was doing was collecting data, it was a much easier approval process. If this was a third-party tool, I doubt I would have been given permission to run it in production. Both Profiler and Distributed Replay can capture trace data, so why not just use Profiler? Profiler can be a bottleneck for high levels of multi-threaded processes. I often liken it to flipping eggs with a fork, where distributed replay is more like using a spatula. You get all the egg in one scoop. If the testing you are doing is impacted by bottlenecks, such as if you're doing performance testing, then it's not a very accurate test. The throttling of replay on Profiler can skew your test results. Distributed replay is truly distributed. Multiple computers for concurrent processing make it excellent for performance testing and capacity planning, particularly in OLTP environments. Distributed replay can support up to 16 physical or virtual computers. The ability to recreate a workflow makes it fantastic for testing indexes and performance issues, whether they are hardware or software related. Of course, no product is perfect or has all the features we may want, and distributed replay is no exception. Here are a few that you may be familiar with from Profiler, which are not available in distributed replay. Particularly line-by-line debugging, a favorite for developers, is not available. So what does make up distributed replay? It's a console tool that requires some setup and configuration. So let's start by looking at the different parts that make up the distributed replay. We're going to take a look at each of these sections of the distributed replay tool and talk about how they work both individually as well as collectively. So this will be the first of many slides of diagrams outlining different areas of distributed replay. The idea is to give you a visual representation of what the tool, what parts of the tool are affected with each action of the tool. As we get into each deeper layer, it can be more complex, and diagrams I find are quite helpful. So let's start with the admin tool. Installed as part of the management tools in the feature selection of SQL Server 2012. It is a console application that initiates, monitors, or cancels operations on the controller. The management tools for SQL Server 2012 can be installed on a SQL Server 2005, 2008, or 2008 R2 server. It's very backwards compatible. This allows the collection of data from instances as old as 2005. However, all replay must be done on a 2012 or greater instance. This is a perfect example of how it can be helpful when doing upgrades. The Distributed Replay Controller service coordinates the multiple clients. There can be only one controller and one administration tool per installed distributed replay environment. This does not mean you only can have one environment. However, for the environment that you're using, you can only have one administration tool and one controller. I'll elaborate on this and when it can be used in that way a little bit more when we get into the discussions of multiple domains. A distributed replay client service is required on each client server. These servers, as I mentioned before, can be either physical or virtual and will work together to simulate the workload on the target server. Distributed replay allows for a maximum of 16 client servers. Each client server will have its own configuration. The target server, this must be a 2012 or higher instance, and it is highly recommended to be a test environment. So we have covered what distributed replay is and what the different parts are, but really how does it all work together? So let's take a look a little more deeper now. Let's look at the different pieces of distributed replay and see what they do and how they work together. As a console tool, you may be concerned that the functionality will be limited. However, each stage of processing and replay of the tool has its own XML configuration file to enable customization. This is another way that distributed replay allows you to use your data your way. So let's dive in and take a look. I mentioned that distributed replay is installed as part of Management Tools 2012 or higher. For ease of explanation, I have diagrammed each of the pieces of the tool on separate servers. However, the blue box here outlines the services that can be combined on a single server. Each server has its own configuration file to allow for customization. So as you see, we can have on a single server a single client, controller, and administration tool. If this is the case, all the configuration files for those individual pieces will be on the same server. This will limit the number of servers as well as make some configuration easier. Each of the XML files can be found in the Tools directory under the DR Replay Client folder for the client configuration and the DR Replay Controller file for the remaining configuration files. Now let's take a look at what level of control each of these configuration files gives us. Within the controller configuration file, the only thing we can configure is the logging level with options of informational, warning, and critical. Yes, I did say they are XML, extendable markup language files. But don't worry if you're not familiar with XML. It follows a standard pattern with start and end tags, and your data is in the middle. The controller file, where the only thing we can configure is the logging level with options of informational, warning, and critical. This is the easiest place to learn. You can see here between the greater than and less than symbols where to make the change to the logging level. So there's your intro to XML. Not as hard or scary as some of you may have thought. With the client configuration, we can modify the controller file location, which is extremely important, the working directory, the results directory, as well as the logging level. This file will be a little more complex. However, the basic principles still apply. Within the Preprocess configuration file, we can modify which system session activities are included and the idle time. The replay configuration file, which is located on the same server as the administration tool, has many configurable options. This configuration file will be used by the administration tool to control all the actions of the coordinated replay with all clients. The details of each of these can be a blog post on its own. So I added a reference at the end of my slide deck with the location where you can find extensive details on each of these configurations for replay. As you can see, there are quite a few, all relating to the actual client running and coordination for the replay. And it gets into quite a bit of detail, giving you as much flexibility and control over how your replay sequences out. With the configuration file set up, you have the ability for action, but you need to ensure communication as well. To ensure proper communication lines, you want to use domain accounts. They can be the same or different accounts for each service. The administration tool is a tool, not a service, and the target server will have the SQL Server instance, which is a different service as well. So what I'm talking about here are the controller service and the client service. If you are using multiple clients, each of these clients will have a configuration file and a client service, both of which need to be configured and set up. The configuration files are engaged and validated when the related service starts on each server that has the service installed. So, for example, the controller configuration file is loaded and verified when the controller service on the server is started. The same is true for each client. However, the preprocess and replay configuration files are not loaded, but used by the controller at a particular stage in the replay. So keep in mind, every single client has a configuration file and service, and the controller has a configuration file and service. Here are some examples of a quick way to restart each service. Just to reiterate, the configuration files are engaged and validated when the related services start on each server that has a service installed. So please note that when you make a change to either the client or configuration file, you must restart the service on the server that the configuration file is located on. This is where multiple clients make for a little bit more work. Each one of those clients will have a configuration file and a service that needs to be configured. So the rest of the story. With MSDN or TechNet, that is essentially the end of the story. But often we forget as DBAs or developers that there are systems and security issues that allow servers to talk to each other. Usually not our department. However, for each of these servers to communicate and allow access, we need to do just a few more things. If after the last configuration file is loaded, we try to run our replay, we will get this error in the error log. Access denied. Well, access to what? Access denied to DCOM, Microsoft Distributed Component Object Model. It is a component distributed across networked computers used for communication of software components, and in this case, the distributed replay. To fix the access error, we need to go into component services. However, if, like me, you don't use component services very often, it's handy to remember that you can access it by selecting Start, Run, and type DCOM-CNFG, the abbreviation for DCOM config, in the run bar. This will bring up this particular screen. Right-click on DR Replay Controller to open the Properties and select Security tab. Here we can grant our service account the proper access permissions. Edit, launch, and activation permissions. Grant SQL Service Domain User Account, Local Activation, and Remote Activation permissions. Note that launch and activation permissions apply the next time the application is started on the server. So keep in mind, this is on the client server. This process will need to be done on each and every client you are running. So if you have the maximum number of 16 clients, this will need to be done on each and every one of them. Now add the SQL Service Domain User Account to the Distributed COM Users group in Permissions under Computer Management. This is a local user group and will need to be done again on each client as well. This will allow the communication needed for distributed replay to communicate to all of the servers, and particularly back and forth with our instance. Again, with any changes to configuration, we want to restart the services to ensure that we reload the configuration file in a state where all changes have been made. So we'll restart all of the services before we move on. So depending on your environment, once the configuration files are restarted, you will likely see one of two different messages. If you get the first one, you're ready to move on. Excellent. However, if you see the second one, you need to open the firewall. So depending on the depending on the formation of your servers and what your sysadmins have set up, you may come up with having to open a hole in your firewall to allow distributed replay through. How do we do this? In Server Manager, on our client again, on the client, open Windows Firewall with Advanced Security. Click on the Inbound Rules. Right-click and select New Rule. This will open the New Rule wizard, and it'll walk us through the process. I happen to like the wizard because I'm not sysadmin, so this is not something I do very often. However, we have to make sure that we have our rules set up correctly. So let's make sure here that the rule we're setting up is a program. You want to let the distributed replay enter through the firewall. So this is a program to ensure a connection can be made to the client and to the controller. Select this program path and browse to the drreplay client.exe. That's the application. This will be at C Program Files, our x86 32-bit version, where our Microsoft SQL Server tools are located. You can see the tail bit there of that path up on the screen. For security reasons, we want to be very specific to our distributed replay client. We don't want to just let all programs through, though it can be easier, not recommended. Next, let's allow the connection and click Next. Select only domain to limit our security issues. Type a name that is meaningful. Here I used Allow Distributed Replay Client. When your sysadmin comes along and asks, what is this for, it's pretty obvious to them. It makes for documentation right in the name. And then we'll click Final, Finish to finalize the opening in the firewall. And one more time, restart the services. Repeat the process of opening the firewall, adding the service account to the distributed COM users group, and setting up the service account with the proper DCOM permissions for each and every client server. Then again, do it for the controller service. There are many steps to getting distributed replay configured. However, you will only need to do it once in your environment. Once this is all set up, and we get to the point of beginning and doing our replay, if you're using the same environment, you'll only have ever had to do this once. It doesn't have to continually be repeated. So although it seems like a large amount of work at the moment, once it's all done, you're set up and ready to go. You can run multiple tests, different types of tests, and continue to use that same environment as long as it's relevant to your workload. So let's check the distributed replay client log and see the message that we had seen earlier, the registered with controller service name. Excellent. But we should also verify the controller log file. This is the information you'll be expecting to see when your configuration of your controller log, file and all connections are working. With all our servers, files, and permissions configured, let's get ready to do some work. The next step is configuration. After configuration is collection. This is where the fun begins. Collection is the process of gathering and preparing the data we want to use. It takes place within both the client and controller, depending on the stage that you're at in your collection. This section defines the collection stages. So let's begin with the trace file. The process to create a trace file may be familiar to you if you have used Profiler before. Open Profiler Trace on the controller server from the SQL Server 2012 Performance Tools. We do that by selecting File, New Trace. Ensure, regardless of the target server, you open the 2012 Profiler, otherwise the template will not be available. Remember, even if you are running the controller for data collection against an older 2005, 2008, or 2008 R2 instance, you must install the SQL Server 2012 Performance Tools. They're backward compatible and will be the only way to access the proper template. The second tab has a list of default properties required for distributed replay to function. In the reference at the end of the slide deck, I have a location where you can get more details on each of these events and collection items. It's recommended, highly recommended, that you start with the template and modify your trace by adding additional items based on your testing requirements. This will ensure that the minimum required properties to make replay work you will have. Once we have the trace run on our server, it's still not ready to replay. The next step in the process, this will produce the remaining files needed to do our replay. The preprocess is part of the admin tool and prepares the trace file for replay against the target instance and produces the remaining files. So the command to run that preprocess is launched from the admin tool and has minimal required parameters that you see here in blue. However, the items in green are optional. But they can be quite important and have a few little tricks to them. The input trace file gives the full path name of the input trace file. Please note that this cannot be a UNC path. So if the admin tool is on a different computer than the controller, you'll have to move the trace file so that it is on the local server. It has to have a fully qualified path name, including the drive. The controller working directory is the location of the local, again local, and fully qualified directory. This is where the dispatch file is stored. Now our controller server name is defaulted to local, so that will need to be changed if your controller is on a different server. Optionally, an alternate configuration file if you want to change some filtering or max idle time and don't want to mess with your default configuration file, which is installed when you install the service. That can be changed as well. And the final status interval is really a default interval. The default is to display status messages every 30 seconds. That can be changed in seconds to whatever interval is more useful for you. Now the last step in distributed replay is the replay itself. It looks like a simple step, but this is also where all the additional action happens. If you are testing with scripts, jobs, third-party monitoring tools, or other items, this is where everything comes together to make your testing happen. Notice how the launch and synchronization happen on the controller. That is so that it can synchronize all of the clients. I have just one client shown here, but the controller is synchronizing the run of the replay on every client at the same time. This is what makes distributed replay so powerful. The command to run replay is launched from the administration tool and has minimal required parameters. Again, the blue parameters are required, the green are optional. The location of the working directory must be, again, local and fully qualified. This is very important. It's also the location where the intermediate files are stored. Now, W clients. It seems, or it did to me anyway, a little odd, but it's the list of names of the client computers that should participate in the distributed replay. This will allow you to have full control over your workload. You can have 3 clients running this time, and if all of them, and then set up more and continue to add, again, to a maximum of 16 clients. This makes your testing very quickly configurable to the number of clients controlling your entire workload. But keep in mind, IP addresses are not allowed, and all clients listed must be already registered with the controller. Remember, this happens when the client service starts. So as long as you had all of those clients set up beforehand, this can be changed very quickly to modify your workload. Now, the O indicates an output file. If not indicated, the summary info is written to the screen only. However, there is a location output file in the results directory element of the client configuration file. That's the DR replay client XML, and can be overwritten there, or you can indicate it here. The server name of the controller will default to the local server again. Target server specified in the fully qualified format of server name, instance name. Often when I see target server, I assume it means just the server name itself, but the instance name is very important as well. Regardless of whether it's a named instance or not, the instance name needs to be included. Simply putting in localhost is not acceptable in this particular situation. If used, the server option in the replay options of the DR replay configuration will not be used. Conversely, if not specified, the option in the configuration file must be declared. So you need one or the other. For the configuration file, an alternate configuration file if stored in a different location. Otherwise, the default is the DR replay preprocess.config, which is loaded when you install the tool. Those we covered earlier. And finally, again, the default interval, here called status interval. Status messages, by default, are every 30 seconds. If during the replay command you specified an output file, the results of the replay will be stored on each client participating in the replay in the directory specified in the command. If no output file is specified, the results are returned to the console where the command was initiated. So that covers how to set up and how to run a replay. But rarely does everything go right the first time. Here are a couple of tips and tricks, the ones that I found most useful when using distributed replay. Change in domain. This one is common, particularly in my environment, where our production environment and our test environment are on different domains. The steps to running in this scenario are the same. However, once the trace file is created, it must be moved onto the controller set up in the test domain. The client configuration file specifies the computer name of the controller. The client will attempt to register with the distributed replay environment by contacting the controller when the service is started. Remember, you cannot use UNC paths for this. It must be local to the controller. You cannot use the same controller on different domains. This is again taking us back to the environment. You can have only one controller per environment, but if you have different domains, you essentially have different environments. For a successful run, ensure that every client configuration file has the test domain location of the controller configuration file and not the one in the production environment. Note again that for any controller or client configuration files that are changed, the service will need to be restarted. Another common issue is this one. This is one of the most common errors encountered, particularly if the files are being moved between domains or even test systems. Sometimes it can be caused by forgetting to restart the services. So when you get this error message, first, verify the location of the controller file and ensure it is the location listed in your client configuration file, and then restart the client services. This will ensure that any changes that were made earlier or that you just made will be applied, and then try again. With many changes, it may take a few iterations of restarting the services to make sure that everything is in sync. Now here is another common issue. It's a bit odd. An empty result set or nothing happens. What could I have possibly done wrong? But possible solutions are that your login IDs, your users, your user default databases, or database IDs are not the same on both the target and the trace database. Make sure that where you ran your trace file database and where you are running against for your target are the same when possible. Replaying events associated with missing or incorrect logins results in replay errors, but the replay operation continues. So it will not error out and stop completely. If possible, database IDs should match on the target. However, this is not possible. Matching on a name can be a suitable substitute. If you have a restored backup copy of the system you collected your data from, you will not likely encounter many of these errors unless you have a significant change to your environment. Typically, what I find most useful is using a production copy backup on my test system to replay actual production data. This reduces this problem. And that's our distributed replay. Your data, your way. I'll take a few minutes now to take any questions. Are you able to facilitate that for me, Liz?
Yep, we're still waiting for some questions to come through, so if you do have questions, please go ahead and submit them.
That was a lot of information in a short period of time.
Yeah. As of right now, you're not having any questions. Do you have any other items that you want to discuss or that you want to point out?
I would like to put up this resource page.
Okay.
For a few minutes. There's quite a bit of information there to get to the extra little bits that we were unable to cover. There's a lot of detail in some of those.
Okay, someone wants to know, what is the solutions-only software?
Oh, that's the company I work for.
Oh, okay. And then someone says, on which server is the 2012 distributed replay tool installed?
You can install that on the server that you want to collect your data from. And then that is the tool that actually runs distributed replay. So that will be installed in your environment where you're going to run your replay.
Okay. And someone wants to know if you have a demo available.
I will have a demo later this month.
Okay. All right. And someone also wants to know if you're going to post the slide deck. So I'm assuming you'll do that on your blog.
Yeah, absolutely. I can do that on my blog.
Okay. And then
there, so you can see that as well.
And distributed replay became available in SQL Server 2012, correct?
Yes.
Okay. All right.
The fact that it's so lovely in its backward compatibility is fantastic. It allows us to take data from older systems and replay them to prepare for upgrades.
Gotcha. Well, I think that's all the questions we have for right now.
Excellent. Well, I can be reached at that information up there on the screen at any time. If you have further questions, I can post the slide deck.
Okay. We did get one last question come in real quick. Since it's installed on the source server, does it pose a performance issue for it?
On the source where you're collecting your data. No, I've run it in production systems, and there have been no discernible notices of slowdowns of any kind. All it is doing is collecting the data as the data comes in, so it's not actually interfering with the process of running whatever your application happens to be. So the short answer is no. Good question, though.
Sorry, well, now we're getting some more questions come through. Can you give examples of things you replay and have found useful?
Most often I use this for performance tuning. Actually, most recently I installed encryption, the TDE encryption for a client, and before running TDE and after running TDE, I ran replays of both daytime type processing and overnight type processing. This client was a bank, so their daytime transactions were from branches as well as from outside sources like ATMs, online banking, that type of thing. So that workload was completely different from their overnight workload, and we wanted to see what kind of difference the TDE would have on the daytime processing as well as the overnight bulk processing that gets done at a bank where all sorts of things are updated. And that type of processing is actually far more intense. So if our processing was going to take longer, we needed to know what kind of an impact that would have, and if it would make our overnight runs longer, if we had to do additional performance tuning for that reason. So that's one way. I've also used it when upgrading instances with different applications, or just upgrading from an older 2008 SQL Server to a 2012 SQL Server.
Okay. All right. Well, I think that's it. Thanks again, everybody, for joining us today. If you have any more questions, please feel free to email me or Melody directly, and we'll be sure to get those questions answered for you.
Thanks, everybody.
Thanks, everybody.
And thank you, Pragmatic Works, for having us.
Not a problem. Have a good one.